Alright, we're down to next case. We got the left side all cleaned up. All nice and clean. And went to the tank there and got it all clean again. So now it's spotless, it's ready for assembly. So now I gotta make some more parts. So now I gotta hone out this pinion race here. Next thing on the list. So this is our bearing we're gonna use, standard. Assuming it works. So I have to measure this up. I'd be shocked if we didn't have enough material in that Harley race to work with, but I've been shocked before. Alright, so we got to measure what these are. These are the individual ones, which I like better than the other ones. The other ones are the long rollers. There's one less roller in there again. Every time they make a change, they take out one roller. And then a long roller will twist on you and not roll. Whereas a skinny one will roll more consistently, so it won't lock up and slide. So now that you have more bearing area, it's better also. The next one above this is the old shovel head, knucklehead, panhead style cage, which has loose rollers that go in here. And then you have one more roller per setup. So the older it is, the more bearings you get. Alright, so we need to measure up the crank here. See what diameter it is. Okay, it appears to be only a tenth or two undersize. Looks like about 2/10 under. Turn it 90 degrees, measure it again. It's right there at 1 to 2/10 under. Alright. Keep that covered up, keep the crap out of it. Okay, so only 1 or 2 under. It varies a little bit, so we'll call it 1. I'll measure what size the bearings are. Standard would be 1/4 inch, which is 250 with a 0 after it. These appear to be on size. These are 2/10 over, so that's kind of weird. Alright. So these rollers are oversized, all the other rollers are undersized. So now these are standard. Okay, so you're right on the 0 here, the veneer scale, right on it. Okay, so these are full size, so that means there's no add-in or no negative or positive on our number. We're measuring just a straight number. That's easier for you to calculate. So just like the rods, we run 9/10 to 12/10, which is basically thou or slightly above. And we're 1/10 under on the other side over there. So we just take 1 off our number. So that means we need to be somewhere between 8 and 1/1000ths. So we'll call it 9. So we pull out our bore gauge. Here's our setting standard. So you want to set this thing to be at 0. You want to set the size you want. You can see how heat and whatever makes a difference. Every time you use these things, they're different. So. Alright, so now I'm getting over. The other view I was over under. Depends on the angle you look at things. Stand it up where you can see it then, I guess. Alright. You're right on 0 there. Okay. This is at room temperature, so it's at standard size. Trying to set these with a mic is a pain in the ass and not real accurate. Okay, now we want clearance. So the shaft is one line under 0, which is 1/10. This is 1/1000. From 0 to 1 is 1/1000. Every line in between is a 1/10. And everything in between each 1/10 is your millions. So I go 1/2 a 1/10, 1/4 1/10, you know, whatever, 1/8 of a 1/10. I split it up. Okay, so right now we're at 1 under over there. We want 9 to 12 is our number we shoot for. So we're gonna figure we want somewhere between 8 and 1 on the dial here. So 8/10 would be right here. 1 is obviously 10. So now we see what we got to actually work with. We're -5 tenths, not thousandths. And it appears to be pretty round. Within a 1/10. Pretty good. Now the problem is in Harley actually using a new case, they're usually like a 8/10 to a thou out around. So I'm not sure they make it worse than when you push it together, but they do. They're really good at doing that. S&S is not much better. They're usually around 8/10, 7, 8/10 out. So slightly better than Harley, but not much. Ultima is usually a lot closer, 3/10 or so. So just because you pay more doesn't mean you get better quality machining. It seems like the bigger the manufacturer, the lower the quality they have for doing the job accurately. Which doesn't make any sense at all, but oh well. Just goes to show you how unimportant it is to be perfect. They prove it all the time on their junk bikes. Okay, so now we're going to go ahead and make it more perfect than they do. So I'm going to shoot for 9/10 and probably give an extra 1/10 for expansion because I can't cool the case, it's too big. So we'll shoot for something like that. Let's see what we get. Looks just like the other mandrel, but this one's bigger. Okay, these stones are for the rods, so we can't use those because they are fitted to a different mandrel. These ones here are fitted to this stone, at least it should be. So we got our coarse and we got our fine. See the different finish? Just like on the rods, we got 2 different finishes. Actually the rod we had 3, one in between these. But this one I don't have the 3rd one. I go right from coarse to extra fine. Okay, turn it down a little bit probably. Put some more. There we go. Alright, ready for honing. Oil on there. See that in the bore gauge, but you definitely see it by holding on to it. It feels always more accurate than numbers. measurement, see what we got. About 3 there. About 2 there. 4 over there. 4 over there. Almost. About 5. About 6.5. And that's about 5.5. Tight spots right here at 4. Close to a 1 for a number. Let's switch out stones now. I could probably get a couple more swipes with the coarse one, but that's about it. I'm getting close on the one side, so it's time to swap around. Okay. Again. Again, a tight spots right here. It's continuing to cut the same way. I feel like it's cutting more out here than on the inside. Yeah. Flip around this direction, which is back of how it normally cuts. Up a little bit. Get a little high spot right there. See if that fixed it. You can make it better or worse, right? 8. 8. Fixed it. 9. 9.5. There we go. See what it does. Stone cuts one way, you gotta compensate and make it do what you want. Get a high spot on the outside edge, it wants to cut that way, so we'll take advantage of it. Shooting for 9 that we're shooting for. Probably got a little heat build up in it, so we'll give it a couple more swipes each way. Call it 10, 9 to 10 what we're shooting for here. Harley can't seem to get anything less than about 1 thou out of air. I don't know why they have such a problem, but I don't lie. There's my number. There's it right there. See, that's on the outside. We move it down to here, and see we're at the same number. Flip it around 90 degrees on the inside. There you go. Come back to the outside way out here. And look at it, we're within a tenth easy. You'll go right in the middle. And there's right in the middle and down there. See, we're within 1/2 tenth. Harley can't get within 1/2 thou. The difference between 1/2 tenth and 1/2 thou is tenfold difference in quality. So. Alright, well there you go. That's how you're supposed to do it. And I was having a problem getting straight until I figured out how to use my stone, and like I said, 9 times out of 10 it cuts more here. This one here wants to cut more about right here where my finger is. It's kind of like a hump right in that area. So I took advantage of it and saved this thing, got it round. It's strictly by feel and how it's cutting. And so anyway, that's how it does. Alright, so I'm going to clean that all up and then I'll check the bearing fit. So clean case one more time.